let me do that again. Today we are starting at day 7 on Advent of Code, and we're just going to jump right into it. As a reminder, we are not going for any particular design, any kind of functional style. We're just trying to solve the problem given the requirements that we have. And then once we move on to the part 2, if there is a part 2 for a given puzzle, the requirements may change, but let's just try to get it done. We're using Swift, and I am doing almost the entire thing in Vimr. Somehow I need to figure out how to actually say this, Vimr or Vimr. I don't know. Okay, so let's go to day 6, and actually let's just go ahead and create our day 7 folder. Day 07. Nope, I do that every time. Day 07. And a day 7.swift. Day 7 static func run, and then save that, and then we'll go over to main.swift and we will add in our day 7.run. Okay. So let's go over to our puzzle. Okay, day 7, treachery of whales. A giant whale has decided your submarine is its next meal, and it's faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines only move horizontally, because of course they do. You quickly make a list of the horizontal position of each crab, your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. Consider the following horizontal positions. I'll copy this. 16, 1, 2, 0, 4, 2, 7, 1, 2, 14. This means there's a crab with a horizontal position of 16, crab with a horizontal position of 1, and so on. Each change of one step in the horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is the horizontal position 2. Okay, so perhaps we could just brute force this one. Just calculate what is the, maybe the range of numbers and maybe get the median or something like that. I don't know. We could go with the range of numbers and calculate their distance to every other number. It seems a little silly if each fuel cost is 1. Move from 16 to 2 is 14 fuel, and then the rest of them are a little bit. Okay, so this is a total cost of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning a position 1, position 3, or position 10. It's, probably beneficial that one of them doesn't move, but in this case, yeah. There were multiples at position 2, so those would all cost 0 fuel because they're already there. So that would be nice. Determine the horizontal position that crabs can align using the least fuel possible. Okay, so let's go ahead and we will have our horizontal positions for our crabs. What do we want to call this? Let's get our input. Our input is all on one line, I believe. Let's take a look at puzzle input. Yeah, all on one line, a bunch of integers. So our input is going to be read file day7.test. And then we can get our positions, which are going to be input.split on the separator comma, and then compact map that to int.init so that we get a bunch of integers. So we can print out positions to make sure that we actually have everything working. Okay, let's see. Oh yeah, we didn't actually put our input in this file, day7.test. Paste that in, quit. It is possible that we may need to get rid of our new line at the very end of this. Let's find out. Build, run. So there's a 14 that we're missing, and that's because when I split and compact map, the last one ends up having the last one has the new line character. So I need to quickly map all of these strings to $0.trimming characters in .white spaces and new lines, and then compact map. Trimming characters in colon. There we go. Okay. And if we run it now, we get the 14. Okay, so that's good. Okay, so crab submarine, sure. Those will be a bunch of crab submarines. I'm not sure if we, just sort of going by what I learned in the last stream, I went quickly to model this as an object, and because it was like an exponential growth type of problem, we ended up with the wrong abstraction because we couldn't model each individual piece. In this case, it's not an exponential one, so maybe that's fine. So if this is a crab submarine and it's got a position of an int, and we still need like a horizontal aligner or something. And this will take this will take in all of the positions. I honestly, even though this is a cool name, I don't think we need this. We just need integers. So this will take the positions, and that'll be an array of int. And then we will initialize that with positions. Okay. So let's create our aligner. Is a horizontal aligner. Positions. Okay. So what we need to figure out are what is the cost of moving to a given position for all of their. So let's say I say func cost to move to position int. And that's going to return a single cost. We can print out the individual costs, I think would be advantageous for us. So we could have some sort of debug output here that says, for P in position, print, this would take the position P, moving to position. Let's call this a target. And that needs to be plural. Costs. And that would be target minus P. And that would be the absolute value of that. And let's just return 0 so we can actually see what it looks like. So we can say let cost equals aligner.cost to move to position 0, let's say. So we can see that going from 16 to 0 costs 16, 1 to 0 costs 1. Okay, so that works. So now we have the cost for individual ones. We can take all of those and sum them up. Let's take the costs to be 0. Let's see, 0 ... less than positions.count. Actually, I could probably say positions.enumerated.map. That gives me the index and the position. And then we can take the cost here. And I actually don't need the index here, now that I think about it. Right, it's just position, target minus position, absolute value. So that gives me the costs. And then when I'm doing that, I can enumerate the two, or I could perhaps zip them together. Zip positions and cost. Could I do that? Yeah, so for pair in zip positions and costs. So that would be position. Could I do P and cost? Okay. Build and run. Okay, so we still have the same result, but now we're storing the costs. And now we can return costs.reduce 0 plus to get the sum of all of those integers. Okay, and then we can print out the cost is cost. Okay, and if we run this, we'll get an actual number at the bottom. Cost is 49. And if we look at the cost to move to position 2, we should get the value that they got in their example. 37, which is correct. Okay, so yeah, so we can brute force this just by finding the minimum of all, go through each one of the values between the minimum value and the maximum value maybe, and then see what it costs to move to that position. So let's see. We'll say minimum cost, minimum cost to align. This is going to return the new int and an int for the sum. I'm not in love with this naming. I could type alias it to make it a little bit clearer, or perhaps give these labels maybe. So this would be the position and the cost. Yeah, I'll do that. So at this point, we need to get the minimum position. That's going to be positions.min or 0 if there are none. And then the max position, positions.max or 0. We could probably just guard let min and max. Let's do that. Else return 0, 0. This indentation is a little bit strange. Okay. Then, so we're just going to go from min position to max position, including max pos. It would be nice to be able to do this in a more performant way where we don't iterate over every single result. But because our input isn't sorted by cost, at least not at the moment, but sorting by cost would still require us to calculate the cost for each one. Okay, so this would give us the min position, max position. So we could say var position is an int. And I suppose I could keep it at 0 and then cost at 0 as well. Because we will, at the very end, we will have assigned this to something. Okay, so for each one of these, this gives us a P. And we can get the cost to move this particular position let cost is, and let's call this min cost and position. So the cost would be cost to move to this point. And we are including, right, numbers that may not have been in the array on purpose because that's part of the problem. If this cost is less than this, we actually need this to be dot maximum or something like that, because we want to get min cost equals min of min cost and then this cost. But then we really don't, no, I can't do that either. Okay, I'm here. Feel free to start over so I don't miss anything. You got it. So here, I'm going to say if this cost is less than the min cost, then we will set min cost to this new cost and set position to be p. And at the very end, we can return our tuple, which was position and cost. Okay, so now I can say let position and cost be aligner dot minimum cost to align, and min cost, let's see, position is, we'll say aligning on position, and min cost is this. Okay, let's build. We should get 37 on this one. And we do. Aligning on 2 is 37. Okay, let's grab our puzzle input and we will copy that and open up resources, day7.input, paste in our input over here. Let's go to day 7 again, switch this over to day 7's input, build and run. Okay, so you can see it's doing quite a bit of work, but we align on 339 and we get this value here. Let's see if that is correct. That's the right answer. You're 1 gold star closer to finding the sleigh keys. Continue to part 2. Okay, the crabs don't seem interested in your proposed solution. Perhaps you misunderstood crab engineering. That is likely. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change in one step in horizontal position costs 1 more unit of fuel than the last. So the first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Okay, for a total of 168 fuel. Okay, so let's move back to our test input. And then we can just change our cost to move. Instead of it being the absolute value of this, it's 1 more than the last. So to cost 1 moves 1. To cost 2 moves 2. 2 plus 1, right? Is that right? So going from 4 to 5 is 1 fuel. Going from 2 to 5, which is 3, is this isn't Fibonacci, is it? 1 more unit of fuel than the last. Second step costs 2. Okay, so yeah, so here I would have to do 1 plus 2 to go 2 steps. To go 3, oh goodness. I need to figure out how, when I do visual block mode, and I want to append onto the line. But that doesn't actually do what I want it to do. Visual block mode. Huh. Ah, there we go. Okay, so visual block mode, then change, C to change. Okay, so the first step is 1, second step is 2, third step is 3, so that is 6. This is 3, and this is 1. And so to go 4, 1, 2, 3, 4. Is this factorial? The product of all positive integers, no. This is the sum. So I need a function to get this particular cost. Yeah, factorial will be multiply. And this isn't Fibonacci either, because this is it's similar to Fibonacci. So to get to 5, so it's the difference. Let's see, distance. Take a range from the difference and reduce to get the sum. Sounds like a good approach to me. So if I take a range from 1 to including the distance, if I reduce this, so, oh yeah, duh. That was easier than I thought it was going to be. Yeah, so you start with 1. Every time through, you add the next integer. So you're basically adding all the indices. Return cost. Okay. Let's help it out a little bit. 1 or 0, it doesn't matter as we are adding. It's true. So it is actually interesting that if I say 1 to 0, we actually get a crash, I think. Because you can't create a range. You can't create a range that is in reverse order. So I think I do need to start at 0 and take the absolute value of the distance. No, I already did the absolute value. Okay. But I do need to, because if you're already there, we can't do a range from 1 to 0, but we can from 0 to 0, and then we reduce it, we get 0 anyway. So that's cool. If we were being really performance conscious, then we would say, guard position not equal target, else return 0, to like have an early return. Okay, let's try this. We get 168 on position 5. Yeah. Okay. Let's switch our puzzle input to day7.input. And we run. This one takes quite a bit longer to run. Let me run it on terminal so I can actually see the output as it's going. I do think that at some point maybe these solutions may be beneficial to have some better visualization rather than just printing these things out. But, you know, we've got to do 25 of these things. Who has the time? Should be nearing the end. 1,347. I also don't know. Okay, so some of these probably could be reused, right? If we had cached some of this so we don't have to loop over every single one every time. Because it feels like this should be way faster. You know, I think the large number I see here is 1,800, so we're 1,000 away, and it's just, you know, it's taking a long time. Printing out the output is part of the problem because it'll slow it down to print out the output, but not that much. Still seems like it should run a lot faster than this. So we do have kind of probably an n squared type of problem here. Passing -O to Swift to make it optimize and run faster. I'm kind of curious how much faster. Don't update Z shell right now. So right now I'm doing Swift build. How do I... Let's see, Swift build help. There's a way to pass XC flags to, like, build flags to this. Let's see if we can find that real quick. Swift build flags. In package.swift maybe. Hello, hello. Apricot. Is it something like -X? It's something like this. I don't know. From Go to Swift. Nice. Were you guys just on a Go stream? Oh, nice. I'm only marginally familiar with Go. I've done some of the tutorial stuff. I'm not sure if I really want to do this. Oh, is this it? Ah, that's what I was looking for. Okay. It will not let me run this, though, however, while this is running. So we are actually almost done, I think. I don't know what the maximum number was. Just curious, what day were you guys on? I have to admit, I'm only marginally familiar with Swift, so that's fair. Yeah. That's what I love about this Advent of Code stuff. It's like, it's useful even if you're not a developer of that language. Today, day 13. I watched a friend of mine did a day 13 stream in Swift. I watched like the first 5 minutes of it just because I didn't want to spoil my own solutions by watching his. So I'm actually looking forward to that one. Basically enough to understand the problem, and that's about it. Okay, let me quickly see what was our maximum number. Well, I say quickly. I don't know. Okay, yeah, we are aligning on 478. So this is probably the right answer, but that took a few minutes actually to run. So if I do Swift build dash X Swift C dash O to add optimized. Okay, let's do this and see if it's faster. It seems a little bit faster, yeah. While that's running, though, I'm just curious. Like, what else could we do? Because I do think I have the right answer, but having it be so slow kind of sucks. This seems like part of the problem, right? So, like, if you are going, let's say you're going from like 1 to 1,000. This is 1,000 iterations. We could potentially cache these numbers so we're not iterating. Like if you're like, oh, I need number 10 and I already computed it, so give it to me. That would help because we're also, you can kind of see like in the positions array, we're mapping from say 10 to 100 or whatever. So there's 90 positions in here. And then when I get to the 100 slot, I'm actually iterating from 0 to 100 here. And so this one is actually, it's interesting because if you've already cached the value, then the one that you want is the value, the one that you want is the value of yours minus 1 plus yours, right? So we don't have to keep iterating over this every single time. So I think maybe we could pre-compute the costs up front. Let's see. So minimum cost to align. We kind of need the min and max positions, right? In order for us to calculate these. Actually, no, we just need the maximum one. Let max equals positions.max. If we don't have one, we can just return a 0 because there's no cost. Okay, so here we could say the costs are going to be a dictionary from int to int, and it'll initially be empty. And costs lookup. Let's call it costs lookup. And then we can pre-compute the costs by saying we want to do these in order. So this would be, let's see, positions. We can do 0 to the max. For each position in. And we want to get the previous position. So I need the index. No. If p is 0, then return 0. And we know that if p is not 0, then we have a previous value. So I can say, let the previous value is costs lookup for p minus 1. Otherwise, give me 0. And this is going to set costs lookup of p to be p plus previous. So that needs to set costs lookup of p. I could probably set 0 to 0 here and then just iterate from 1. There's a formula to calculate adding integers from 1 to n. There's a math called triangular number. Oh yeah, that would be way faster. N times n plus 1 divided by 2. That's it? Seriously? Okay, I am curious if this solution works, but I will refactor it to use that solution. Okay, so we've got the cost lookup is the previous cost lookup plus our number now. I think that would work. And now instead of doing this, we would say, just give me the costs lookup for the current position. And we can force unwrap it because if it's not there, we made a mistake. Okay, so how long did our solution take to run? 276 seconds. Horrible. Okay, so let's go here. We're going to build, and we're going to run time. Wait, did I build? Yes, I did. Time Swift run. Your solution will be faster after reaching some point. Well, it does spend a fair amount of time up front once, but yeah, so now we're in 4 seconds. Let's do what you were saying. So I think this cost to move to target needs to probably have a private func cost to move distance and have a distance be an int. And that way we can, iterate on this separately. So their cost to move distance. So if we had this, and then we can return cost to move distance. Oh, shoot, this has to be pre-computed. Oh, you know what? Sorry, I was already having a problem. I need to pre-compute these costs. So this would be private var costs to look up. Because I was running cost to move, n times. Cost to look up is the int to int array. Dictionary, sorry. And then this would be pre-compute costs. Private func pre-compute costs would do all of this stuff. Let's move this up here. Pre-compute costs would go from 1 to the max point, which we compute here. And then cost to move distance would just look at the costs lookup for distance and force unwrap it because, again, that would be an error if we ever did it incorrectly. Costs lookup. Okay, self is immutable because, yeah, it's interesting. We need this to be a mutating func because we're in a struct. It's kind of annoying, honestly, that I feel like that probably could just say, yeah, let's do max int returns the dictionary that we want. And then, oops. And then this will be static. And then we move the max here. If let max, we will we'll do pre-compute self.costs lookup is self.precompute costs for positions.max or 0. That way it's not a self method, and because we're still in a struct, it doesn't necessarily matter. This needs to create the lookup. Int to int. Empty, return lookup, and then this can be lookup. Look Okay, so now we've pre-computed the costs. Cost to move distance should just use that. Cost to move distance for distance. Okay, so we were at 276 seconds, then 4 seconds. I feel like this should have been faster. Yeah, that's 3 seconds. Okay, so now going back to your solution earlier, let me get rid of this and say that formula is slightly different whether the number is even or odd. When n is even, n times n over 2 plus n over 2 and n odd. Oh, is it? Yeah, because it's an integer division. Well, you could use floating point and round, right? It would probably be fine. So this would be, so let n is distance. We're going to return n times n plus 1 over 2. That's the essential formula. N is always even here. No, it's not always even. The distance could be 1. So, yeah, so like in this case, if we pass in n as 1, that's 1 times 1 over 2. So 1 times 1 over 2, which is the same as 1 over 2 gives me 0. No, that's 2 over 2, I'm sorry. So that's 1 times 1 is 1, so that would be correct. If it's if we pass an input of 2, that would be 3 over 2, which would be 2. For 3, that would be 4 over 2. Is that right? So then this would be 6. So then for 4, that would be 5 over 2. So this would be 8. And I don't think that was correct, right? So 5 over 2 would give me 2. Yeah, that's why I think that shouldn't this be floating point and then round at the end so that you can account for the odd and even in the same one? What were our numbers? Yeah, 1, 3, 6, 10. Yeah, so we're off here and here because we don't account for that overage. So if this is then floating point, then this becomes 2 times 1.5, which would equal 3, which is correct. And then this one would be 5 over 2 is 2.5, so that'd be 4 times 2.5, which is 10. Yeah. Okay, so let's do this. We're going to float this. Let's just make n float here. And then turn the whole thing into an integer at the very end. And I'm suspecting maybe I don't need any rounding. I don't know. Let's see. The answer was 478 and 96,000. It's not 96,000. What is this? 1, 2, 3. 1, 2, 3. 96,086,000. Okay. I'm just going to copy that. Let's build. And run. $2.5. And I got the same answer. Okay, I think we have a winner. Yeah, there are no squares in here or square roots, so I think that this is better in essentially all cases. I don't think that my lookup would ever be faster unless we had to deal with squares or square roots, and then at some point I think it may be faster. Yeah, so let's just clean up all this pre-computing stuff. Yeah, I did say that we're not going to worry about performance, but in that case, it was pretty egregiously horrible. And this was kind of the function I was looking for, but is there a name for this function? Maybe I missed it in the chat. There is a formula for calculating integers from 1 to n. There is math called triangular number. Triangular number. Counts objects arranged in an equilateral triangle. Triangular numbers are a type of figurative number, other examples being square numbers or cube numbers. An nth of a triangular. Okay, yeah. I've never even heard of this concept before, but it makes total sense. And obviously these numbers are the same. Only 2-second delay from your previous solution. Yeah. I mean, 2 seconds is a lot. 2 seconds is quite a lot. I still think there's probably a way to do this even faster. Let's try it with, I'm curious when we build it with optimizations, what the difference is. And I also want to try it without printing. Oh, it also seemed like it built the... Yeah, hang on a second. When I do... I did a build, right? And it gives me this build complete stuff. But then when I say Swift run, I wonder if it should just run the, let me just run the executable myself. What is it? Build slash ARM64 debug advent of code. Yeah, I'm not sure why when I do a build, when I do a Swift run again afterward, that's 1.6 seconds with optimizations. Okay, so now let's take out the printing of all the costs as we're iterating, because that is almost certainly a big part of the cost of this whole thing. So now we will build with optimizations. And run it. And now we're at 0.01 seconds. Yay! I don't think we can shoot for much faster than that. So, and I still get the same number. So let's actually make sure that this number is correct. I still haven't plugged it in here. That's the right answer. You're one gold star closer to finding the sleigh keys. You have completed day 7. You can share this victory or return to your Advent calendar. Sweet. Okay. Yeah, so today I learned about triangular numbers. That's awesome. Also noted that printing repeatedly to the console is mega slow. And yeah, that was cool. Thank you so much for the participation in the chat. I had a lot of fun. If you're new here, I would request that you subscribe to the Twitch stream so you can be notified when I go live next. I'm kind of doing these ad hoc because I don't have a ton of time. So when I realize I can fit in like an hour stream, I will just go live then. So I'm also posting these to YouTube. So if you follow the NS Screencast channel on YouTube, you can see the recaps of each day, a few days delayed. So, all right. Any parting questions or comments before we wrap it up? You know what I just realized? Yes, I do post these to GitHub. That's a good point. Let's go do my ritual to stage all these files. Commit. Day 7. And we will push. It is GitHub subdigital/advent of code. I believe the link is on the YouTube videos as well. I will make sure about that for future videos. I just realized though that my stream chat has not been showing up on stream at all. It's been blank. I wonder what the problem is there. Yeah, more stuff to figure out on my streaming setup, but maybe I'll have to download some sort of plugin and show it on my screen. But okay, awesome. Well, I hope everybody has a wonderful Monday, and I'll see you again in the next stream.